Hey everybody, I'm Dortz, and this is the C++ Pointers and Functions tutorial. And here, if the name doesn't give it away, I'm covering pointers and some basic function protocol stuff. So, the first thing we don't know that we see is these guys. These are declarations for functions. I have the basic syntax for the actual function definitions, which is a type variable, a name for it, and type variables separated by commas, well, just types, not variables, obviously, for anything that we're going to intend to pass to the functions. And here we have function commands and stuff in brackets. But for just declarations, you don't need the brackets, it's just a semicolon, because you're just telling the compiler, hey, I've got these functions, be sure to watch for them. Here I have pass reference, and two overpass functions. We'll go over all these in turn, but first, how about some pointers? Now, a pointer is a variable that really is just something that points to a specific location in memory. Whatever location, say, in this case I'm going to be setting these pointers to these integers, whichever memory location that these integers live, that's where the pointer is going to point to. So I can set these ones here. This ampersand sign means the address of. So it lets us say, okay, now P1 points to 1, P2 points to 2, and we have here allows us to set values for 1 and 2 through the pointers by using the reference key, which is just the star, and that lets us say, okay, now 1 is going to be 5 and 2 is going to be 10. You'll see that later when we compile. And another major point with pointers that really isn't useful for integers, but say when we get to arrays, it'll be crucial. This is dynamic allocation. And this uses the new token. So we have an integer pointer, pDynamic. We say pDynamic is going to point to a new integer. So what this does is it allocates an integer space and lets pDynamic point right to that integer space. But we also need to clean up after ourselves when we're doing dynamic allocation, because again, it's not going to be a big deal when it comes to integers, but when it comes to you calling a function that has a dynamically declared variable in it 1,000 times, it's starting to take up a large chunk of memory, and that gets into memory leaks and stuff, where the amount of memory that your program is using just starts ballooning over time. Because if you don't delete the allocated memory and release it back to the memory pool, then it's just going to keep grabbing more and more memory. And this prevents that, and it's really good coding practice to just get into a habit of deleting it the last time you're going to use it all the time. Obviously, you need to delete a pointer that you know exists. So for every new, there should be a delete. So it's, I guess, dangerous to the integrity of your program. I'm pretty sure it'll just spit an error at that point anyway. But that's enough of pointers. Now for the real fun part, functions. So here we have pass1, which pass, as we saw up here, is one of our declared functions. Where are we? There it is. And here we are calling pass. And that's just variable name and what variables we are going to send to it. The types need to match up, and let's run down past the end of the main function to our function pass. See, it looks almost exactly like our declaration up here, except for a couple main things. Here we have an actual name to access the variable as, and brackets instead of the semicolon, and obviously stuff to do. So it says, hey, I'm pass, and it got X. Now, we sent 1, but we could technically send a random number, because all it's expecting is an integer value. So it gets an integer value, and it just calls it X. For the whole life of the function in this specific call inside these brackets, it knows X. And then X is just automatically forgotten by the program after this. You don't have to declare it because it's technically declared here. So here we have, it does stuff, prints stuff to the screen, and then we have return X, which I'll cover this in just a second when I make note that here we have after pass. It didn't actually change the 1 value, it just changed the X value that it knew. But here we have 1 is equal to pass 1. This is where the meat of the return token actually comes into play. Because when you return X, you send the integer value X back. So we can have 1 equal pass, and the 1 plus 5 is going to equal 1. And we'll see that in just a second. But there's one more fun way to do this, which is pass by reference. A note up here, we did declare it with the ampersand character, which we know is the address of. So here we have pass reference, so we're passing the address of 1. And drop on down to pass reference, which is basically the same thing. I don't know why, I must have not finished my commenting. Whatever. This is going to change the X value it knows, but it's also referenced directly to the memory location that 1 lives. So technically it can be thought of as a pointer to 1, and you're editing it without having to reference it. And it just automatically does this. Another thing to note, and the rest of the functions in here are going to be void. Void is a new type. It has no value associated with it. And say we have a void function, then we don't have to return anything from that function because it doesn't expect anything to be returned. You can also not do anything like, 1 equals pass. We can't do 1 equals pass reference because pass reference is not returning anything. You got all that? Okay. So say we get back from pass reference. Now 1 has been changed by pass reference. So now 1 is actually going to equal 15, as we already have 1 equal 10 from here. So 1 should equal 15 when we get to the compiler side, and we'll see that later. One more thing to cover before we go over there is overloading functions. An overloaded function is simply a function with the same name, but different things are passed to it. They can be different variable types, or they can be different amounts of the same variable type, or a combination of anything. They just can't be the same. You can't have overpass int and overpass int. Here I have overpass int and overpass int. These two do nothing but demonstrate that you can have two of the same function declared, just with different parameters. And we'll see that it's just going to spit out random text later. This is more of a conceptual thing right now. But you can see how it can be pretty useful. If, I have the suggestion for a calculate function up there where it'll take different ints, doubles, floats, whatever. But Yeah, all you coding pros out there really shouldn't be watching C++ intro segments, and I'm really not sure why you aren't skipping over it. But yes, there are better ways to implement a calc function, but we aren't there yet. So that is the end of our main function. We return 0 as for proper coding practices. And let's head on. So here's the output. It's never going to change, so I didn't really bother. I obviously already compiled and ran the code. Notice just the things we said were happening are actually going to happen. Like after pass reference, it's 15. After we set 1 equal to pass, it's 10. Yay, I suppose. This sample output, as well as the code itself, are going to be up on the show notes. If you have any questions, hit me up on IRC, and have fun. Later.